In this video, I'm going to analyze the data relevant to the study that examined whether photos of children who are sucking or not sucking their thumb yield different levels of likability ratings from other children who are looking at the photos. And in this study, what's important about it, as I write in the textbook, is that there's no time order associated with these levels. So it's not pre-test, post-test, and follow-up. It's not how many exposures, 2, 5, 10, 25 sort of thing. It's really, truly nominal in a sense that there's no order. Suppose you could put boys and then girls, or girls then boys, or sucking and not sucking, left to right, but really there's no obvious order to these data. And importantly, the researchers actually randomized the order with which the photos were presented to the children for rating. So they didn't just put boy sucking thumb as the first photo for all children, and then boy not sucking thumb as the second photo. They actually randomized the order with which the photos were presented to the children. So different children got different orders to make sure that there was some counterbalancing going. So to analyze these data, you'd analyze it in exactly the same way you would for any within subjects design with one independent variable. And we might just put here photo and four levels, define, put the levels in here, and options, descriptive statistics, effect size, and we'll plot the means, but you'll see that we'll really underscore the point that there's no order. And that also means that doing a trend analysis for this study would not be an option. Trend analysis only makes sense when there's some sort of order associated with the independent variable levels. So you're left with having to put photos in here, compare main effects, and because we have more than 3 levels, we can't do the LSD, but we can do the Bonferroni. Now, because we're doing Bonferroni, we don't actually need to do the ANOVA. We could go straight to the comparisons, but I'll just follow through with the entire analysis that's outputted by SPSS. So first you get the measures box, and you can see that we have our 4 levels associated with the independent variable, which is photos. And we have boys sucking and girls sucking. You can see that the means are lower than when not sucking their thumb. So obviously the children are responding to that, at least numerically. We don't know if it's significant yet. Now, Mauchly's test of sphericity was violated in this study, and so we've got p less than 0.05. So we cannot look at the sphericity assumed results, and I would recommend looking at the Hunfeld results. So we'll do that because we violated the assumption of sphericity. It's less than 0.05. So looking at Hunfeld, we can see that the f value is 11.92 and the p-value is less than 0.05. It's in fact less than 0.001. And so we've rejected the null hypothesis, and partial eta squared is 0.234. So it's a pretty big effect size, although surely there are correlations between these levels. So let's actually look at the correlations. Should all be positive. And in fact, we get positive correlations in the ballpark of 0.5 to 0.4, which is the sort of thing you would expect. So the null hypothesis of equal means has been rejected based on the omnibus ANOVA. Now again, because I did Bonferroni multiple comparisons, I didn't need to do the ANOVA, but you get it automatically. There's no way not to get it in SPSS. So here are the pairwise comparisons. So comparing photo 1 to photo 2, and you constantly have to keep in mind what that is. So it's boy sucking versus boy not sucking the thumb. So it is a mean difference of negative 2.78, and that is statistically significant, 0.022, and that's Bonferroni adjusted, so I'm protected here. So the difference between photo 1 and photo 3, which is boy sucking versus girl sucking thumb, was not statistically significant. So there's no difference between the boys and the girl in the photo sucking their thumb, so no mean difference there. And then the difference between photo 1 and photo 4, which is boy sucking thumb and girl not sucking thumb, is also statistically significant. Another comparison that's statistically significant is 2 versus 3. So that is boy not sucking thumb and girl sucking thumb. That is statistically significant, 2 versus 3. But 2 versus 4 is not statistically significant. And that was comparison boy not sucking and girl not sucking thumb. Was not statistically significant. So the last comparison that's unique is this one here, 3 versus 2, which is girl not sucking thumb and boy not sucking thumb with a 0.08 p-value. So it's kind of cumbersome to have to do it that way. Unfortunately, we just don't get the labels here in SPSS. But we obviously rejected a large number of mean comparisons. And you can see here that there's no real trend. There's nothing to actually evaluate here from a trend analysis because it doesn't make sense. There's no sense in the order. So that is me analyzing these data that are different than the first two examples because there's truly no order in the independent variable across the levels. And there's still something very interesting to derive from this sort of analysis. And obviously the conclusion is that when males and females, boys and girls, are sucking their thumb, they get a lower rating than when they're not sucking their thumb when children rate their photo.